everybody, Tired Metalhead Weatherman here. Hopefully you guys are doing well at the time you're seeing this video. So one thing to make note of here is the fact that severe weather during this time has been a little bit quieter, so I'm kind of going back to roots here. Those of you that have been around the first year of the channel, because we haven't even been around here 2 years yet, but those of you that have been around here more so towards the beginning, you kind of know what I'm getting at here. Keep the content rolling. I'm gonna go back to the Weather Nerd 101 playlist, especially since we're starting to draw closer towards winter, and this one could be an interesting winter at that, with the shift that we've had from La Nina to El Nino. So I figured, why not actually go over the oscillations a little bit and over what El Nino is, La Nina, and much more, because this is going to be a big influence behind the weather pattern that we will likely see this winter. So make sure you smash that like button, decimate that subscribe button, and obliterate that share button as well. So we're about to dive in here. So in order to understand what's going on with El Nino, La Nina, you have to understand just what a climate oscillation is. So climate oscillations are naturally reoccurring changes of the Earth's climate associated through oceanic and atmospheric conditions. Usually, whenever we look at these regions here, and there's 9 oscillations in total, the easiest way to pick up on this is through the sea surface temperatures, which we'll get into how to read that a little bit later. But there's 9 principal climate oscillations. I'll name them all here, but I'm going to talk about several in particular. We're not going to talk about all of them tonight. We're going to talk about the one that's most relevant and the one that you all know without really knowing probably. But the 9 principal climate oscillations are El Nino and Southern Oscillation. There's the Pacific Decadal Oscillation, or aka the PDO. The NPO, which is North Pacific Oscillation, North Pacific Gyre Oscillation, which is the NPGO. The AMO, Atlantic Multidecadal Oscillation, the NAO, North Atlantic Oscillation, the AO, or the Arctic Oscillation, the Antarctic Oscillation, and then the Indian Ocean Dipole. So those are the 9 in total, but considering the fact that most of my viewing audience lives here in North America, there's 3 that we'll end up covering over time. The main one that we're going to be covering is, you guessed it, El Nino Southern Oscillation. And it's this one right here, this bad boy. And I'm betting some of you that haven't really been into the weather until recently are probably thinking to yourselves, what the heck does this thing have to do with influencing our weather when it's all the way in between South America and Australia? You would be surprised, but this isn't the only influencer behind that. The AMO is a part of the trifecta here, or really I wouldn't even call it the trifecta. It's much more than that, but it's part of the picture here, but not quite as prevalent. It's multi-decadal, so you have to think over multiple decades. So it's a player, but not as prevalent as one as you might think. These 2, however, the Arctic Oscillation, North Atlantic Oscillation, much different story. So that's going to be something that we talk about later down the line, but we're mainly going to be honing in on this one right here, the ENSO, in this video. So let's go ahead and get into the ENSO here. And the term El Nino refers to the interaction, of course, between atmosphere and ocean climate between the central and central equatorial Pacific, or South Pacific, let's say, in layman's terms. So the ENSO region, there's 3 phases with this, and this is where you need to pay attention, because this is how you come up with the El Nino, La Nina, and much more. So the El Nino and La Nina are actually phases for this area here, this oscillation. So El Nino, and we're going to go to a different screen here. So El Nino is when the waters over this region, the surface temperatures are warmer across this region, usually above average, because there is a neutral point here, and in fact This is what that neutral point looks like in this graph indicated above. There's 3 phases, like I said before, and this is the La Nina phase here, where we're seeing those cooler than average temperatures become more dominant. So basically, let's recap that real quick just to make sure I have this, I've covered this properly here. So neutral ENSO would be where we see the water right about at average, I would say. And then La Nina is whenever you would see the surface temperatures of the water across this region cooler than average. And then, of course, like we said before, El Nino is whenever we see those surface temperatures warmer than average. And the way you would tell what kind of phase that this area is in, that this El Nino or this ENSO region is in, so to speak, is you usually will go to a different section. There's different sections of it here, but the main one that you would look for is Nino 3.4, and this is how you can find it on one of many different websites here, but there's a graph that kind of indicates everything for you. So on the Nino index here, there's 3 different areas, of course. The plus side is considered to be closer towards El Nino. The negative side would be a little bit closer to La Nina, and then of course in the middle is neutral ENSO, as it's called. So as you can see, and this is actually looking at the index at current time, we're in an El Nino, and actually towards a pretty strong one. Usually anywhere close to 1.5 is considered a pretty strong El Nino, and the same can be said for a La Nina, except it would be a negative 1.5. Anywhere between positive 0.5 and negative 0.5 or 0 either would be considered as a neutral ENSO. So not going to try to draw anything on the graph as far as that's concerned, because I'm not a great artist. I probably would mess it up and have other weather enthusiasts or weather nerds probably screaming their lungs off at me. But simply put, that's basically what the ENSO phases are and what they would look like. So the impacts is probably what you're wanting to know the most. I can probably hear a few of you now saying, Ty, just get to the point already. Just give me a moment. But the neutral ENSO, you can kind of get a little bit of either or, and that's partially where those other 2 oscillations come into play. But the impacts in the US during the winter from El Nino and La Nina, and keep in mind, this is a typical pattern. There are a lot of things that change, and that, like I said, those 2 other oscillations come into play there. The way the jet stream sets up as well comes into play, but typically what we'll see here, and this is what we're going to be looking at probably for a good portion of this year, because these don't stay the same throughout a 90 to 120 day period. So with this setup here, it seems like it's going to be warmer more so towards Alaska and parts of Western Canada. Towards parts of the northern tier of the US, warm air could be stationed over this region. Now keep in mind, this does not mean that you are going to be seeing 60, 70, 80 degree temperatures over towards this region. It just might be a little bit warmer than average. Polar jet stream is going to be a lot further to the north here, so the likelihood of cool downs will still be there, but it may not be quite as frequent as what you would see with a La Nina year, where we have the jet stream in a much more active look just based off of this right here. And with this blocking high right here, creating a ridge over areas like Alaska and parts of northwest Canada, when we get this trough that starts to develop, it'll just bring all of that cooled air down into the US, usually around the heart of the country, sometimes even towards the southeast. Could be a battle zone there. But with El Nino, it's a little bit different. Sometimes towards the northeast, we could be seeing much cooler air. We could see a more prevalent storm track towards that region. And then there's this other jet stream, because we actually have 2 that end up over the US. My first video on the playlist will actually kind of go over that for you. But with this little secondary jet stream, which is a subtropical jet, it's going to create a more active pattern over the southern parts of the US here, and slightly cooler than average temperatures seem more likely with this. Usually the cooler air, of course, will be stationed a little bit further towards the north, but not saying that it can't make it much further to the south, but Usually the storm pattern, with the jet streams being more active to the north, will usually leave the south out and will have us looking a little bit drier and warmer. Not to say that things can't happen during La Nina years. We've seen many examples of that. There's many years that in particular that I can think of. 1998, 1999. La Nina years were pretty wild, especially towards the winter. And then El Nino years, there's examples. I remember seeing my first white Christmas in Atlanta in 2010. It was during a El Nino year. So there you go. But that being said here, like I said, these are not shoe-in weather patterns here, and these do fluctuate. So that being said, we do have to keep an eye on the weather pattern, which of course I'll be doing here on the channel, but just make sure you're keeping track along with me if you would like to. You don't have to, obviously. So here's another graph that gives you a better look at what the El Nino and La Nina temperature patterns look like here. So here's El Nino, like I said, warmer than average waters over here in the Enzo region, and then there's the cooler than average waters here towards the Enzo region caused by La Nina. There's other ways you can kind of look at this too. The chart is probably the most reliable way to me. But if you were to look at the sea surface temperatures currently, you can clearly see it very warm. This is actually an indicator of a very strong El Nino. Whenever you see the temperatures above 1.5 degrees Celsius, which we're seeing a lot of indicators of, especially within that Nino 3.4 region here. And if you don't know what I'm talking about, it would be this region right here. It's the closest thing I've had to a decent rectangle here. Well, I just ruined it. But anyway, this is the Nino 3.4 region right here in this box. And usually that's where most of the samples are taken for making the Nino forecast. Some ways that you can keep track of that, of course, would be going through the Climate Prediction Center and the National Weather Service, of course, and also the National Oceanic Atmospheric Association as well. All the links to the sources that I used here and some of the other sources that I used off screen will be in the description. And I'm going to wrap this one up for now, so that way we can talk about other oscillation regions soon. But until then, I hope you guys enjoyed this video. Hopefully you found it useful. If you did, make sure you smash that like button, decimate that subscribe button, and obliterate that share button again. Appreciate you guys being here. See you soon. This has been Metalhead Weatherman. You guys take care.